Good morning, crowd. Welcome to Prague. We're about to start our first meeting at IETF 104 and routing working group. Here we go.
So we're going to start today with the usual update of the routing area working group document status. First, of course, note well, you've probably seen this several times, but if you haven't really taken the time to read it yet, please do so. I wanted to point out that for the routing area working group, we have the general IETF IPR disclosure policy, and the way that we handle that specifically in the routing area working group is requiring the authors and contributors to state whether or not they're aware of any relevant IPR for a document in question at the two main gates for the document process. That is at working group adoption and also when doing working group last call. And sometimes we'll do this concurrently, sometimes before, depending on the specific document. We have our minute taker who's just arrived, and we also have Drew doing the Jabber scribe work. Thank you. The blue sheets are in circulation, so please sign them. They're used to figure out what size room we get next time. So please sign them. I think I'm going to jump right into the document status update, and then we'll start the actual agenda. So we've had 3 documents published recently. The LFA multi-home prefix draft became an RFC, and also the network instance Yang model and the logical network element Yang model were published. We have 3 drafts that have been submitted to the ISG for publication. The Yang model for RIP is awaiting a normative reference, so there's not much that the authors or the working group need to do there. I think it's waiting on ISIS and OSPF Yang models. The microloop problem statement is in Auth 48, or rather Auth 48 is done, so that's pretty well along. The PA multi-homing draft, it's in AD evaluation, and actually the authors need to respond to some feedback. So the authors will be doing that. We have one document that's past working group last call quite a long time ago, the BGP PIC draft, and we're really expecting a Shepherd write-up very soon on that. We've nudged the Shepherd. Recently adopted working group drafts. The segment routing TILFA draft was adopted, and the net to cloud problem statement and gap analysis drafts were adopted, as well as the RIB Yang model. They were adopted. So in terms of existing working group documents, the ATN BGP draft has been a document for a while. We're going to hear about that today. The routing policy model draft is also, I don't think we're hearing about that today, are we? The source test routing draft, it was adopted quite a while ago. It's sort of recently been unexpired. And we also have the VRP, BFD point-to-point draft and the routing timer parameter synchronization draft, which were adopted quite a while ago, but they've expired. So we probably need to figure out, how we're proceeding with those. Either the authors bring them back into circulation, or we'll figure out, if there's still interest in pursuing them. Okay. So the policy model will be presented on Friday. So in addition, several drafts that have been discussed over the last several IETFs in the routing area working group related to control and user plane separation for BNG. There's a BOF occurring basically in the next session this morning after the break related to those drafts. So we're not going to discuss them here because there'll be a BOF dedicated to them. So I think I will bring up the agenda now, and we'll start with the scheduled presentations. So first up, we have Fred Templin presenting on the ATN draft as well as scalable BGP related to that.
Okay, so this is a document that's been in the working group for a little while now. It's paralleling the efforts that are going on in a organization for civil aviation called the International Civil Aviation Organization. And this is the routing system that we're looking at for air traffic management for civil aviation. The document's titled, A Simple BGP-Based Mobile Routing System for the Aeronautical Telecommunications Network. So in terms of aviation and communication standards bodies, the International Civil Aviation Organization is developing an aeronautical telecommunications network with Internet Protocol services for worldwide air traffic management. We have other standards bodies that are involved in this too. RTCA Special Committee 223 is identifying an IPS architecture for remotely piloted air systems, which are also known as unmanned air systems. RTCA SE 228 is identifying communications data links for RPAS coordination. AIRINC and AEC also have a stake in defining their own standards. And then finally, the Internet Engineering Task Force is the worldwide authority for in-networking standards. So we think the way this is going to go is that these communication network standards have begun in ICAO, are being harmonized in RTC, AIRINC, and EEC, and will end in the IETF, and that's why we're here today. So in terms of what the ATN IPS looks like, again, it's currently under investigation in ICAO Working Group I. It's based on Internet Protocol version 6. It's an overlay network over an underlying internetwork that could be either secured tunnels over the public internet or a private infrastructure. And we want to have a single air traffic management service for all manned and unmanned aviation. Each aircraft gets an IPv6 prefix that travels with the aircraft wherever it goes. And we need to have remote pilots, air traffic controllers, and aircraft globally addressable at all times. So in terms of scaling considerations for aviation, each aircraft is a mobile network and it receives an IPv6 mobile network prefix, for example, a /56. And that prefix goes with the airplane wherever the airplane travels. Worldwide today, we have on the order of 10,000, possibly growing to 100,000 airplanes in operation today. However, with unmanned air systems, personal air vehicles, growth anticipated in the near future, we're going to need to consider soon large orders of magnitude. And then mobility plays a role in control message overhead, and aircraft are highly mobile, so we need a system that scales, not only in terms of the numbers of nodes, but in accommodating mobility. So one alternative that is being looked at is what we can call centralized mobility management. And that would be a case where we have one mobility anchor point for the entire worldwide aviation. So you see all these airplanes here grouped around a single anchor point. The advantages of centralized mobility management are that we have immediate mobility signaling and quality of service signaling, since all aircraft are serviced by the same mobility anchor point. Disadvantages are that we have scaling limitations, not only in the numbers of aircraft, but also in the amount of mobility signaling. And also, localized mobility events cause global instability. So we believe that this is not going to scale. And so now we have this option that we call distributed mobility management. And this is where we get to the ATN BGP document. With the ATN BGP document, we have a hub and spokes architecture with a BGP routing core in the middle as an overlay network over the underlying network, and stub autonomous systems in the spokes, where you see those mobility anchor points with aircraft grouped around them. So this is the way we can distribute the mobility and the quality of service signaling, is by having smaller mobility anchor points that service smaller numbers of aircraft, and the global overlay routing system tracks which aircraft are associated with which mobility anchor point. Advantage of the distributed mobility management approach is that it distributes the load among many mobility anchor points, and it's scalable in terms of the number of aircraft we can handle out of a BGP routing core. Now, the internet is proof of concept that we can handle upwards of close to 1 million routes in the BGP routing tables. With the distributed mobility management approach, we also have scalable mobility signaling, and localized mobility events are kept local without causing global instability. The disadvantages of this approach, though, is that it requires an effective route optimization service to reduce congestion in the core. Otherwise, we would have all traffic going through that core, and we would have a concentration of congestion in the core routers. But the good news is that we know how to do the route optimization. So in terms of the draft in the routing working group, we have a BGP overlay routing system for distributed mobility management. Again, a hub and spokes autonomous system border router arrangement. We have core autonomous system border routers in the hub and stub autonomous system border routers in the spokes. BGP updates are unidirectional from the stub autonomous system border routers to the core autonomous system border routers. And the core autonomous system border routers in the reverse direction simply originate default. So we have partial topology knowledge in the stub autonomous systems and full topology knowledge in the core. Now, BGP is the design is for carrying short-term forward of initial data packets only, and then route optimization kicks in to keep the data traffic out of the core. And this is a very important point. We've had some experimental evidence over the course of the last several weeks showing that when you withdraw a BGP route from the routing system, it can take several hundred milliseconds for that route to disappear and for new routing information to come through. So that we found that after we've done route optimization, if we remember where the aircraft was before the BGP update happened, then we can continue to forward at the link layer without going through BGP routing. And in that way, we avoid periods where we might have several hundred milliseconds of packet loss. And that's very important for aviation applications where we can't have dropouts in voice over IP. We can't have loss of position information, things like that. So even though we have a BGP convergence time, we take care of that at the link layer without impacting the routing system. The mobility management services in the stub autonomous system border routers, ICAO is looking at 3 alternatives for the mobility management. Proxy Mobile IPv6, Lisp, and Arrow are the 3 candidates that are being looked at right now. Now, in terms of the document status of the routing working group document, we did update to a version -01 recently. We incorporated clarifications due to list comments and questions. Also, we had a routing area pre-review that we responded to. We have a new section 7 on the stub autonomous system mobile routing services where we talk about PMIP, Lisp, and Arrow. And then we updated references and included new references for MIP v6 and Lisp. Now I want to talk about, did I miss a slide? I'm missing a chart in my deck, okay. So now we have this concept that we call massively distributed mobility management. And this is a case where we have not just one BGP core with its routing information base, but many BGP cores that each have a separate routing information base. So we want to size the system to support a mobility service prefix on the order of a /32. Now each one of these BGP routing cores maintains an independent RIB with up to 1 million routes per mobile network prefix routes per RIB. Each RIB would service a different sliver of the mobility service prefix, and we're calling that the mobility group prefix. So for example, if each RIB serviced a /44, an IPv6 /44, then if we had 1,000 RIBs, that would get us to 1 billion BGP routes. And again, the way we get to that level of scale is by having multiple RIBs that are independent of one another. But even though we have these multiple RIBs, the aircraft, when they move from mobility anchor point to mobility anchor point, can get the service that is being provided by their sliver no matter which mobility anchor point they move to. So this is how we get our scalable deaggregation for massively distributed mobility management. And I think that's all I had. So in terms of draft status, we have the simple BGP-based mobility routing system for the Aeronautical Telecommunications Network. That's a working group document of this working group. And we have the new document on scalable deaggregation for overlays using the Border Gateway Protocol. So that's a document that we have aligned with this working group, but we haven't asked for adoption on that one yet. And that's what I have, Jeff.
So I had a question. You referred to some like experimental data, and I think at least this second draft refers, kind of talks about that a little bit. But could you just elaborate a little more on what you're doing to sort of test the scalability of the whole solution? And
yeah, so we're actually working with a group in Austria from a company called Frequentis, and Frequentis was chartered to evaluate these mobility solutions for the ICAO work. They ran an experiment where they were sending 100 packets per second through the BGP routing system, and then withdrew a route from the routing table. And they noticed that over that 1 second period, they were losing 20 to 30 packets out of that 100 packets per second string. So that's where we get the notion that we're talking about several hundred milliseconds of outage when a BGP route is withdrawn before the system realizes that route is no longer there.
So do you think you would be able to reference some work that's done, or maybe have an appendix that describes the problem found and how it was fixed? I think it would be very useful for people looking into this work.
I think that's a great suggestion, and we can work with the Frequentis people to get some text for that.
Thank you, Fred. For me now.
So good morning, everyone. This is Qing Wu from Huawei. I'm here to discuss how to use leverage the IETF-defined model to automate network management to deliver service. And so this is the draft that we actually packed for a long time. Actually, we bring out because recently we see a lot of IETF-defined model get published, mature enough actually. So one motivation actually is we want to raise some IETF young data model standardization issue to inspire some discussion on this. So we also see actually, for so many young data model, actually how they can put together to deliver service, configure the device, may different people have different solution. So we really want to get people, to understand how to use this model. Secondly, actually, it's one of the big challenges for operator, because we talk with a lot of operator. The big challenges they're facing actually how to use this model, how to select the IETF-defined model that can fit into their use cases. So this is something we need to face actually for the IETF. And so the draft I proposed here and the work I proposed here actually to provide the framework that tells the developer, implementer, operator how to implement the IETF-defined model. Also discuss top-down service delivery through the coordinated young data model. This coordinated young data model will cover high-level model and lower level. How they can coordinate it is not clear to everybody. If we get time, actually, we can give one or two use cases to discuss this. So before we get to discuss, actually, I want to introduce two concept. One is data modeling layering. Second is data modeling representation. Data model layering actually allow you to abstract the network infrastructure from bottom. Also allow you to abstract the business needs, service requirements from the top. So the service, so the young data model in IETF can be split into two layers. We have service model can tell you what a service is, what is the customer service needs. And for device model, they can tell you how to, get a network set up to program the networker and deliver the service, realize this service. This has already been specified in RFC 81 1990. But we see actually what is missing is in the middle is the network resource model. Actually, this network resource model is very crucial for you to deliver the service. For example, you need to schedule the resource to meet the customer needs, or you can reschedule resource to adapt to the network changes. So it's very crucial. So we introduce this, another layer. Also for data model representation, we make an analogy to the house building process. For example, first, you need to plan the house building, and then you can put it into the production. For the house building process, your customer actually can order the house, describe their requirements. For example, you want to order a house with 3 room and living room, bedroom, and this can be actually represented by the blueprint. So the blueprint can be compared to the service model. So the service model can be used by the customer to communicate with the operator, communicate with the management system. So in addition, actually, when you get approved by the customer and also regulation authority, this can put you into the production, and actually you can you can actually select the site. You can put a foundation for the house building, and you also can actually establish the trench for the water supply, electric supply, and sewerage. Actually, this water supply, electric supply can be compared to this network resource model. And also for the foundation with the house building and the building block in the house can be compared to the device model. So the question?
Yes, Greg Mersky. So are you familiar with the work at MEF on services, uni, and lifecycle orchestration?
I think it should be actually be listed as actually service model. They provide the service definition. So this service definition actually very close to the service model defined in IETF.
No, because there layer 2 service model, layer 3 service model defined by IETF defines it from operator perspective. MEF approach is defining uni, N, and I, and defining the model from their subscriber perspective. What you're describing here is very much what MEF is already doing. So
I think the similarity for MEF work and IETF work, they both actually describe the connected service. Actually, for L3SM and L2SM model, actually, they do actually describe the service from the customer perspective. For example, how many VPN sites you want to describe, you want to establish it, and what is the location of this VPN site, how to establish the connectivity, what is the KPI or SLA for each connectivity. So it's very close to the UNI you mentioned. Actually, we already compare this with MEF terminology, and we were aligned with MEF. I think there's no conflict, but we do need the coordination between MEF and IETF. Yeah.
Carrier Ethernet model that defined by MEF being used to order services. I don't know where L2SM being used to offer order services. MEF works on layer 3 UNI. It's a MEF 61 document already been published, and continues working on operation ENNI. Also, it works on service OEM, service activation testing. So I would really suggest to be very careful not to do duplication of the work by SDO.
We have already been aware of this, so thank you for your information. Actually, we already tried to align with MEF. I think we actually, this is just a two ecosystem. We do need more coordination, except the bridge actually. So that's why I bring up this topic, but not on the focus of this topic. Actually, we can take this offline and for how to align with other SDO. Yeah. Okay, so for next, actually, I want to give an update for the IETF network young work. Actually, I think recently we already published more than 50 RFC, and also in addition we have more than 80 working group jobs. Actually, get progress proceed in IETF. Another maybe more than 80 individual jobs, and we have enough young data model. Many young model get published recently, especially before this IETF meeting. So, and I think this should thanks for the design team formed by the IETF, like many design team formed by the vendor and operator and distributed in different protocol working group. And also we have young doctor design team and young coordination design team. And I think they fulfill their mission, but I think still we have some work we need to actually to put some resources to see how to get some work actually can really be used for some real use cases. So also I want to mention IETF have good collaboration with different organizations, also have get a lot of input from the open source community like Open Config. Actually, many Open Config innovation actually has already been the input to the IETF and drive a lot of innovation in IETF. So this is very helpful. So we hope actually for open source and IETF can converge at the same point, but it's very challenging. But really it's our hope to see different organizations, different open source can align with each other. Yeah. So this is the whole overview of the IETF for young model standardization. We have high level model, service layer model. We have actually common building block in the middle. We call the network resource model. We also actually define some mechanism like scale mount actually can help to compose different model together to actually to configure the device to program the network. So this is very crucial to automate the network management. On the 9, actually, we have a large amount of young data model actually cover different technology spec actually. This model actually, many of them recently get published, but we also see some of the issue. One issue we want to raise here to inspire some discussion is, for all of this, we call the device model, SaaS-bound interface model actually is distributed in different protocol working group. Actually, it's hard for user or for the operator to select this model to fit in their use case. It's hard to keep track of the maturity for all of these models, because they are distributed different protocol working group. Actually, maturity may be different. We also have a very slow IETF process, and maybe many problem in IETF, they lack the resource to put into it, so they will delay some of the young data model standardization. So this is really a serious issue. We should pay more attention. Yeah. Actually, for the trend, actually, we really evolve from traditional service delivery to the model-driven service delivery, and the big difference actually, for traditional service delivery, OSCBS actually, they didn't really, they actually couple the service definition from how the service is realized. So that cause actually you may build a lot of OSCBS application and build a lot of silo over years. Actually, they lack a standard interface, and it may involve a lot of data entry and manual provision. And so this actually cannot automate the service activation or provision. And so to address this, actually, what we can do is in the model-driven service delivery, we can decouple the service definition from how the service is realized. So for the management system, we can split it into two subsystem. One we call the service activation provision system. The second is service enforcement system. So the service activation and provision system just take a standard model from the standard interface, and this will greatly, reduce the service delivery time, and go back to the traditional service delivery for management system. They need to, tackle the multi-vendor environment. They need to manage different vendor device. So it's very challenging because you need to deal with the different vendor CLI script. And so how do you automate this network management? Very, very challenging. Based on our talk with operator, actually, many operators actually just integrate different vendor CLI script and try to identify different vendor device and call the different vendors CLI. So this is something we should address. That's why IETF, proposed a standard model to address this challenge. Actually, So how do you automate the management? Actually, I think we automate the management can from two different layers. One is the service layer. The second is the network layer. For service layer, as I discussed in the previous slide, actually, we can actually define top-down service delivery model and to describe the service requirements, KPI and SLA, and associated with the connectivity service. And but you really want to automate the service management. You also, what is missing actually, you need to have when you get a network set up, you also need to expose the network performance or expose for example VPN performance to the customer or to the operator. They can use these performance results to re-optimize the network. So you can form the closed loop management, full life cycle management. And in addition, at the network layer, you also can automate the network management. In IETF, we already developed a young push notification as a telemetry mechanism. You can leverage this and to connect the data. And actually, you will automate this network management. What is missing is network policy model. This can be part of this management system. They actually can to hook the telemetry data with the provision data and to really automate the network management. And I think we already developed a lot of building blocks in IETF, especially southbound interface device model. We can leverage this, but what is missing is actually policy-related model. So I see some of the policy-related model has already been progressed, like ACL and routine policy, but what about the other policy, Q's policy, maybe generic network policy? This is still a very important building block that can help to automate the network management. So, yeah.
Again, Greg Mersky, so speaking of lifecycle orchestration, I think we at IETF is far behind comparing to efforts being done, for example, at MEF in lifecycle orchestration for now carrier Ethernet and now for layer 3 services. I would encourage you to really look at what MEF is now at the level and what other components, because, for example, it seems to me that you're dismissing, for example, service activation testing model, service OEM model. So these are very important ordering models. And
but the service OEM model is carrier service, specific. In IETF you can leverage generic mechanism like YAM push and telemetry. And you also can define the loss bounding with telemetry mechanism to connect all the data.
I don't want to turn it into tutorial what service orchestration, lifecycle orchestration is. I just encourage you to look at what MEF is doing and maybe revisit what you're proposing.
Okay, thank you for your suggestion.
Rob Wilson, Cisco. It's actually a question for Greg. In terms of what's happening at MEF is, obviously they define the LSO model at the top layer, the service layer. Are they writing any draft models to say how you map those services down onto, for example, IETF YAM models to instantiate those services on the devices, or is that left open? I mean, is there somebody doing that piece of work between the two? There's models at the top, there's models at the bottom. Yeah. Who's to say how you bridge between those two things?
Work on layer 3 is only being developing. They do have already a life cycle for carrier Ethernet, so it's layer 2. And layer 2, they have demos and they have real working system to do end-to-end service ordering and provisioning and monitoring and decommissioning. So again, it's not layer 3. Okay. So
I think the question is IETF define large
again,
amount.
I think that's better we take it offline. But again, I suggest you to avoid duplication and incomplete proposal. Look at what MEF is doing already, because they're using ONAP and they have pretty good lead on that.
I understand. Actually, that's just architecture. I think we do need some reference architecture. We may actually leverage this area. So, but in IETF, I think we do need to actually maybe have such a reference architecture to help developer operator to see how to position different model in different interface and help the operator implement this YAM model. And also, I think it's very important to help to understand how to map MEF service definition or service model to IETF development. It's very crucial. It's what is the missing. I would encourage you to do this. So that's why we already engage with MEF to talk about that, how to fill this gap.
Charles Eckel, Cisco, and I'm active in MEF. I co-chair the application committee where we're defining an SD-WAN service and what that is. And obviously it overlaps and perhaps even conflicts in some places with work going on in IETF. Chid and I have already talked. This is something we're going to try to align better. Overall, what I've seen in MEF is there are service level models. They don't, the way MEF defines service is different than the way IETF defines service. Most places in MEF do not have a complete stack built out yet that's all using MEF specifications. At some point, it starts with a MEF service model and then switches somewhere to either some proprietary implementation or some models that are being defined within MEF. And we see this as a problem because we'd like to be able to reuse a lot of the underlying IETF device models and perhaps other models as well. So one of the things we're going to do with SD-WAN is really look at trying to align those two bits of work, since they're both being defined actively in IETF and in MEF. So I think we have a good chance to kind of show the way this can work. And that's something we're going to actively work on this week and afterwards.
Yeah.
Young Lee, Huawei. Actually, I'm also active participant of MEF. I think Chin's approach here is data model driven with RESCOM, NECOM consistent from layer 7 to layer 0. And MEF approach sometimes depending on the interface, they don't have data-driven approach. They rather do some open API or some other spec without Yang model. So I don't see any conflict between what Chin is trying to do here and what MEF is doing. Architecturally, there's some similarities, but in terms of approach, how to implement, there's some difference. So I think as Charles talk about SD-WAN, same thing, layer 1 service model developed here. Actually, I brought it to MEF so that they can take it, so that we have same consistent model. But they have a little bit different idea. They don't want to sometimes use Yang model. They want to spec-driven to UML, to JSON schema, to open API. It's a REST API, but slightly different flavor. I think market will decide which one is the right way to go. But I think definitely within IETF, Yang and RESCOM has security built in. So I think it's much easier to implement from security perspective as well. So I don't see much conflict. So I disagree with what Greg is saying in some sense.
Thank you.
Rob Wilton, Cisco. So just to provide some other general comments on the presentation or the material you're presenting here, I have a lot of sympathy with what you're saying in terms of IETF producing a lot of models by independent working groups. And there's some efforts to make sure those models are consistent with each other, but I don't think there's very much looking at the bigger picture of how do you actually then implement services? How does an ISP take this large set of models and then implement the services? And sometimes it's obvious, and in other cases it's not. It's actually having some informational draft that gives some guidance that says, if you want to implement this service, these are the models you'll need to use on the device. This is the set that we'd recommend. So I think that more work to actually look at the bigger picture as providing services for both on the device and off the device is a useful thing. I think there's useful work to be done here. And I think the work of trying to map like these service models being produced by other SDOs into the IETF's device models, again, I think that's very useful work that otherwise is left to the ISPs to actually figure out how you connect these two things together. I don't know if I understand exactly what you're asking about in terms of the extra layers and things here. I don't know if they're required, but in terms of providing the documentation of how you can take those top-level service Yang models and the bottom-level device-level Yang models and say, look, this is how these things map, I think that's a lot of value in that area.
Yeah, thank you. Yeah, this is something, this is one of the key motivation we bring up this topic. Not sure this draft actually, ready for that, but we really want to provide a reference actually to have, to define the module list that can actually to provide support different service. That's exactly what we propose to do. We also talk with best working group, actually try to see if we need to have such a mapping from service layer model to the device layer model, and but maybe it's very challenging to do that. But we do try to actually, for example, conduct a survey to, solicit the feedback from the operator to see what is the key service or how provided service they really deployed and what kind of technology they really used. And but I'm not sure how to, try to achieve this goal. And so this draft try to, bring up some issue and inspire some discussion and get some feedback to see whether we need to, bring up some new work. And I think if people have interest, then we do need to work together to see if we can actually help to address this challenging issue faced by the IETF defined model. Yeah.
And then, so one other piece of work that I've brought to NetMod is a Yang packages draft.
Yeah,
and the idea of that
piece.
is to take sets of modules, could be IETF modules, and group them together into, say, this set of modules is what you'd use for a basic router, or this provides high-level routing, or provides LTVPN service, and you can piece these things together in a hierarchical way to build up larger complex systems and still be able to manage those independently. So that is potentially one solution to this problem. Another way that's been proposed is to use the module tags I think it's working with last call. That's another way of labeling things and grouping them together. So there are different ways you can solve this problem with different pros and cons, but it is interesting area.
Yeah, you are right. Actually, I didn't mention this two important work. Another, actually, I want to mention is the Yang catalog. Actually, I think IETF we put a lot of resources in Hackathon to actually develop the Yang catalog. Right now, it migrates to the IETF repository, and this is very, very important actually reference for help operator developer to select the Yang data model. But maybe this is not enough. We do need some additional input to see how to make this Yang catalog more be aware by the outside the community, and also operator can leverage this kind of tool to measure the maturity of the Yang data model. That will be very exciting.
Just interrupt. So I would like to disagree with Greg on overlap. If you look at MEF documents such as MEF 61, they are not abstracted enough to provide service definition. They are not detailed enough to provision a service. So people who work in both SDOs would be great if you facilitate the process of building something that could be used in more layer model. So Greg and Yang can we've been working with MEF on and off for a number of years, right? It's just, there's very little progress.
Yeah.
This is Chung Feng of China Telecom. It seems to me that a lot of Yang model has been defined, but actually most of them has not been widely used in carrier network. So I think that this draft provide a systematic framework to integrate the Yang models into a production system, which can be used in a network of carriers. And for example, mapping the service model into the network models and provide service automation, which is very crucial, important for carriers. So I think this work is very useful. I give support to this work. Thank you.
Thank you. Yeah, I think carrier just the one user or consumer of this IETF defined model. We also have some other customers. So I want to put this service model as a customer service, to satisfy the customer needs. Yeah. Actually, we already discussed, service management automation and network management automation. We also see, you need to hook the service management automation with the network management automation. You can provide the end-to-end and the whole full automation system. Here, what is very important piece actually is to do the service mapping. So we have two cases in RP scenario, and a T scenario. In RP scenario, you need to actually map, for example, the layer 3 VPN service parameter into the configuration parameter that can be enable the BGP, ACL, OSPF in the P and C. And for T service mapping, you really need to, map the service definition within the T service into the T tunnel and into the T topology. And this is also very crucial to help to automate the resource management. So the resource management is very crucial, but it also is very challenging, based on our talk with our operator. Yeah. And so last actually is our takeaway, and we actually have two use cases. Maybe we don't have time to introduce, so I just jump to the key information we really want to convey in this presentation is first, we think for IETF, Yang, the process is slow. We already know this, we complain a lot, but I think we can do something, we can focus on some model, for example, the BGP and the VPN related young data model is crucial to deliver the VPN service. So we should, put more attention to this and get an operator to involve to see what is missing and try to drive the maturity of this kind of young model. Also, we think it's very important to engage the operator community. Right now we already many model already get published and mature enough. So we really need to create a young standards actually that can meet the relevant network operator requirements. Actually, what we can do, actually, we can conduct survey, as I mentioned. Also, young catalog, we also actually already discussed is very powerful tools. So how to leverage this tool to measure the maturity of the young data model. Also, the bigger issue is IETF young model is not use case driven. This young model, distributed in different working group. So how to, keep track of this maturity of young data model, So we really need to shift to the use case driven or project driven and to help to, make some of the young model more useful for some specific cases to really address the, pain point or requirements from the operator or from the customers. So last, actually, we defined this reference framework to tell you how to, do this top-down service delivery through coordinated young data model. This is something, one big motivation to write this work. Also, last, we like to advocate for developer, for operator, it's time to deploy this IETF model to, identify some implementation issue, get the operation experience, feedback to IETF community to help drive the maturity of IETF model. That's all. Yeah.
Thank you. So personally, I find your goals great, and hopefully we achieve them. Ignas, who is outside in the room, and I think he's going to say a few words about the topic.
Ignas Bogdanas, the wrong type of AD in this room. So thanks for raising this. There are quite many of painful points that you're mentioning. On the other hand, you seem to be kind of proposing certain solutions, and that solution seems to be, let's add another layer of the models and it will solve the problems. That probably will not happen at all. So a few of the specific topics. IETF process is slow, yes, that's a fact, but proper cooking takes time. And looking at the deliverables of certain element level models and technology level models, I think that time is worth waiting. Then another aspect about the secret sauce between the service models and the element models. That is just a reality. If the vision is that we will define one set of service models for all interconnection products, which are even built from a standard technology components, that is not realistic. Different users, different operators implement their own connectivity products in different ways for different reasons and valid reasons. And the secret source component will always stay there. The question is, to what proportion, but I don't believe it is practical to try to eliminate this. Then about the quality of the models and ability to use them in the hierarchy, I think that is a big problematic area. IETF is historically very good at working on fragmented technology components, but not necessarily on end-to-end systems. And we see clear results of that. We do have technology models which work for that particular technology domain, but they implement the same functionality, not necessarily in an interworkable way. And if you try to stack different technology components one on top of the other, you end up with problems. This, I think, is an area which needs to be addressed first by this. And if your work can start by this direction, that I think would be a good outcome.
Yeah.
That's just an overall general comment from a manageability point. Thank you for the work.
Thank you.
Thank you.
Can I say a comment? So Stefan from Orange. So you say that it's time for operators to deploy, but in fact we can't because first there is almost no implementation. and there is no implementation because there's too few models that could be deployed today. So let's say that, for example, I have only the IETF interface, which is available in my device. I can't use it because it does not make sense if I cannot also configure my ISIS or BGP or whatever. I need all the full stuff. So this comes back to the point, which is, yes, IETF is slow, but it's not only a matter of process, it's also a matter of people, because I think all know that. We are slow to progress documents, and it's not a matter of processes, it's just a matter of people and resources that we are allocating to progress our documents.
Yeah, that's good feedback. Actually, just want to mention, in Intech, they do actually have multi-vendor interoperated tester. They test some of the service model and some of the network element model, so they could be actually first step to see how to deploy the IETF defined model. Yeah.
And the other point.
So we're running 5 minutes behind at this point, so we probably.
Just very small comment. The other point about IETF model is that from an operator point of view, we have now a lot of implementations of OpenConfig, which is ready to use now. So will we really use IETF model? It's almost not sure.
Yeah, we can, I think there's no confidence. We hope we can converge for IETF defined model, OCEON model, and the OCEON actually they do have some deployment and they more mature, but and I think IETF model, if they can catch up and they actually can, I think they focus on different use cases. So IETF model more promising, because they try to harmonize with OCEON. Yeah, that's what I see. Thank you.
Thanks a lot. Next up is Donald Eastlake.
Hi, I'm Donald Eastlake with Huawei. If we're a little behind schedule, maybe I can catch up because I think this is a fairly short, simple presentation. It's on a point-to-point tunnel policy Yang data model. So it's kind of has policies because there are these variety of tunnel types you might have to provide VPN services. And you need to be able to select between these. They're not necessarily all available depending on what you have implemented and what's currently functioning hasn't yet failed or whatever. So this draft provides a Yang data model can be used to configure and manage your point-to-point tunnel policy. And it kind of assumes there's two flavors of policy, a sort of a selection sequence and a tunnel binding. Selection sequence assumes that you have a series of different tunnel types, and you sort of select from those based on the priority they've effectively been given for a particular VPN service. It's if the tunnels can be flagged as the particular tunnel can be flagged whether it's up or not, and you select from obviously from the ones that were up. If you have multiple tunnels, you can select them for load balancing purposes and things like that, but obviously avoid any tunnel that might be marked as being down. And the tunnel binding is a case where you sort of bind the particular policy to a particular kind of TE tunnel. You can specify multiple ones of those to the same IP destination to get load balancing effects and things like that. And you can kind of say what happens if they're not available. You might want to restrict it to only the ones you specifically bound, or if those tunnels are all unavailable, you might want to just do the best you can. So there's a attribute which you can associate which indicates which of those sort of meta policies you would like to have. It's kind of a selection sequence order for different tunnel types. If there's no TE tunnel available, Basically, there's a case where if the designated tunnel is unavailable, it looks at this switch to determine what other tunnel to select, and then it has a sort of ordering between those tunnels depending on tunnel type. And then, of course, there's always the possibility that no tunnel will be available that your policies allow, in which case you can't establish the VPN connection. So the top level, there are these tunnel policy selectors, and there's an ordered list of these. So you got to go through in order until you get one that matches. So each one of these policy nodes, whatever, has a set of matching conditions based on various conditions, next hop, RD, or whatever. There's obviously more details in the draft. And to match a particular policy node, you need to basically match all of these selectors. And if they do, then there's various apply policies which specify the tunnel modes, section tunnel mode, and which tunnels you specifically would want to use. And there's also the possibility of including in there the mode that if none of those match, then you deny a route. So it's a fairly simple model, I think. So I think the draft is in moderately good shape in terms of possibly being eligible for adoption vote. We'd like to ask people to look at the draft and send comments to us. We'd be happy to improve it and working on update it. And at some point, we think it would be appropriate to ask for working group adoption.
Rob Wilson, Cisco. Just one question: Is this intended only as a device level model, or is it intended as a service level model, or is it something that could be used in both places?
I think it's a little more of a service level model. But
right. Okay. Okay.
Same thing. Hi, my name is Tariq Saad. I'm with Juniper. There is some work that we're doing in Dee's working group to model the tunnels on the device, off the device, as well as steering on the tunnels. So I'm not sure if the scope is to provision the tunnel in your model or for service steering on the tunnels. A little bit confused. Yeah. And is it only packet layer tunnels that you're interested in, or basically maybe steering on SR policies also is in the scope?
It's I think it's really kind of to do with the assumption that you've established, you decide you're establishing a VPN, and you need to select the tunnel mechanisms that are being used for that VPN. That's the point of view it came from. If there's related drafts, we'd love to know about them.
Yeah, draw your attention to
either send to the authors or to the list, whichever.
Sure. Yeah. Okay.
Thank you.
Yeah, thanks.
Pawan Biram, speaking as Dee's chair. The drafts that Tarek alluded to, both of them are on the agenda this afternoon. Okay. So, yeah, if you want to check it out.
I don't remember if I have a conflict, but it sounds good. Thank you.
Igor Bruskin, Huawei. Basically, I just wanted to add the same thing what Tarek and Pawan is saying. We have quite a few documents which describe how services are mapped on tunnels, and explicitly and implicitly, for example, through tunnel pools, and how you actually separate the couple services from the mapping, and who exactly maps services on tunnels and stuff like that. So it seems like overlap here. So basically,
there may be. Perhaps things should be merged or whatever. I don't know.
Jeff Oz. I looked at your draft. The model's perfectly fine for a lot of applications. I think the thing you're going to run into is something some of the other models in IETF have a tendency to run into is you're sort of namespace squatting on a really nice name for an application that is potentially too narrow. So I'm going to offer by example the access control model that got worked on also partially here, which gets used in very specific applications that really is not a completely generalized ACL model, but was very useful for things like MUD and other applications. So my suggestion is the model's fine, continue working on it, but consider changing the name to be something a little less generic.
Okay.
Dhruv, my suggestion on the reading of the document was that it's more better for a device model, as in when you configure a VRF, you want to configure the tunnel policy along with it and specify that this is my preference or this is the particular tunnel that I want it to be binded. So when I read it, to me, my gut feeling is device, and the other work that's happening in T's with respect to service mapping at a higher layer. So then I think it will be a very clear demarcation of where the work stops and where the work is happening, my suggestion.
Okay, thank you.
Ruberger, the other T's co-chair.
Okay.
If your focus is really on tunnels, I think the work should come to T's, and you'll find that maybe all of it is there except that maybe a couple of pieces of information you might want to add, or you may find it's all there. If your focus is more on the VPN information, you can do it wherever you want. Maybe best is a better place, but you'll need to coordinate with those models that are being developed in T's. So either way, you want to know about those, but depending on what your focus is, you may find you just want to either merge or use what's there in T's.
Okay.
All right. Thanks.
Thanks for all the informative comments.
And Donald, I would expect you to coordinate with TS to see what should and could be done.
Okay.
Thank you.
So next up is Rob Wilton talking about the ARP Yang model. And I apologize, I left this off the list of the working group documents, but I've added it now. So this is a working group document that we're talking about here.
So you've probably hit saturation on Yang models, so this one will be quite quick. So hopefully you won't fall asleep. Okay. So I still want that. No,
I'll do it for you.
So there's not very much. Just to recap, what does this model cover? There's already some basic ARP functionality in the IETF IP Yang model, so that allows you to configure dynamic artworks and static ARP entries. So what this draft is covering is the extra bits of ARP that are not in IETF IP that lots of vendors have support for, and it's not covered. Examples of this are like ARP packet statistics on interfaces, proxy ARP configuration, GRAT ARP configuration. Next slide, please. So this is the current tree on the latest draft. We've actually, in terms of the updates, and I'll go over those in the next couple of slides, what we've been doing, we've simplified it and taken some stuff out that we didn't have consensus on between the authors on the fact that everyone's implementing these in the same way. And I've highlighted two leaves there that I'll talk about in a little bit more. One is the enable leaf for GRAT ARP, and the second one is a discontinuity timestamp for the statistics. But as you can see here, this is a pretty basic model. There's one extra global leaf. There's a bit more stuff on the interfaces and the augmentation in terms of an expiry time. Next slide, please. So what have we changed? Mainly, it's been editorial improvements to improve the introduction text, the security sections. We just try to improve that. We've also gone through and cleaned up the model a little bit more. We simplified it in places. As I said, we've taken a few things out. We try to align the configuration at the global level and at the interface level to make it a bit more consistent for hierarchical config. We've taken out global static ARP entries. I've taken out the ARP probe configuration. Again, that wasn't standard. And there was a GRAT ARP drop configuration flag that also been removed. What else we've done? So there was a dynamic ARP global default setting that's now on by default to try and make that more intuitive. As I said, I've aligned the global interface configuration together so that these are the same names and the same defaults. Formatting has been improved. And then I've added a discontinuity timestamp for the ARP counters. Now this is the one of the issues I would like to raise to get feedback on what people think about this. So the next slide. So of the two issues, the first one is there's a set of ARP statistics that we're reporting on the number of ARP packets received, what the type of those packets were, and the ones that were sent. And the question is whether the ARP statistics should have their own discontinuity counter to say when those counters are from, i.e. what point do those counters actually count from. Now there's a few choices here. I've added one in here. Another choice would be to say just reuse the interface counters discontinuity counter. So you'd assume that the ARP counters would get reset if you reset the interface counters and that the two are aligned. So that's one choice. You could keep them separate as I've done here, or perhaps you could say it's implementation defined. So you could say that if this counter is provided by the implementation, that's what it means. And if it doesn't, then it's up to the implementation to specify. So does anyone have any opinions on this, on which way we think we should go? If we don't hear anything back, then we'll discuss with the authors. We'll update it one way or another and see if anyone objects during working with last call. Any thoughts?
Jeff has, so it does seem a little bit weird that you do have it there, and I have two pieces of thinking on that based on classical SNMP type MIBs. If you really do have two separate internal subsystems that can have distinct discontinuities, having that sort of thing makes sense.
Yep.
That said, and I'm not paying as much attention to Yang models as I used to, but I think this is the first time I've actually seen a specific submodule have its own discontinuity thing. Yang has been sort of architecting itself towards like a cohesive view of things.
Mm-hmm.
So you're now putting in a hint to the system that some pieces of a tree could have a completely different idea of counters than the other one, and that makes correlating the two very tricky.
So, and I don't mean like when the router's rebooted, which is one standard discontinuity time. I'm thinking more that sometimes if somebody's come along and cleared statistics for some purposes, then that's the one I'm worried about. And maybe in the Yang model, you just don't allow that. You don't clear the statistics. You always just take if you want to see the change, you just take a stamp at one point in time and look at another one. And in terms of the subsystems, in terms of what you say, it might be better then for this not to be in the model, and if a vendor wants to do that, they add it in their own model, and then they modify the description statements to say this is how it's changed. That might be a bit safer.
Right.
So, okay.
Yeah, and I don't think it's necessarily a wrong idea, but I do think that it's sort of novel, and rather than making Rtgwg the victim of something that's interesting, maybe the core conversation off the net mod, because this is a more general problem.
Yeah, okay, thank you. Next slide, please. And then the second issue, again, is a minor one. So at the moment in the model, the gratuitous ARP setting for the interface has been left as effectively no standard default. So it's up to the vendor implementations to decide whether they do gratuitous ARP by default and whether it's on or off by default. And then it gives explicit use a way for a client to be able to decide to turn it on or off. I wonder, I sort of don't like these ambiguous defaults in Yang models. I think it makes them harder to use. So my question is, would it be better to actually say that gratuitous ARP is on by default, and that would make life a bit easier for clients and things. But I didn't know whether that's okay to actually say, well, that's the right thing to do.
Sorry to monopolize the microphone. This is a thing that platforms are going to have an opinion on. If you choose something in the default model, it'll be wrong for some platforms.
That's maybe okay, because they still have a choice to deviate it, and they have a choice to deviate it and remove it. They have a choice to deviate and change it. So we've had this case where it's come up internally about auto-negotiation on interfaces. What should the default be? And IEEE has changed what their position is over time as that technology has matured. And so in IEEE, that's on by default, whereas our manageability model has it off. And people are arguing internally to say, oh, well, let's make it ambiguous. But I just see that as really hard. Nobody knows whether it's on or off until they explicitly configure it. I don't think it's easier. So that's why I'm arguing to try and say, look, try and get rid of these ambiguous defaults where we can. But if it's truly the case that everyone's different here, then you have to leave it vague, I think.
I think most people that have a good security standpoint would argue that off is probably the same thing to do. The thing that, based on your comment, you may want to specifically put a comment in the module that a module should supply deviations to actually cover the system form of things.
Okay, that seems pragmatic. And I think I had one more slide. So just in terms of the remaining work, I think we're fairly close to being done on this, I think. There's maybe a little bit more tidy up and clean up. Those two issues, we can act on those and update the draft. So I think that maybe we might not have that much more to be done before we're ready.
So would it be fair to say after we resolve both issues, we will start with young doctor review?
Yes, I think so. That would be good.
Great, thank you. We'll do so.
Next up is Greg Mirsky.
Thank you. So this is. Oh. Okay, this is an update on talk I had probably one meeting back. We're getting there.
Almost.
Yeah. Well.
Yeah.
Looks. Thank you. So, when how it started, looking at how new encapsulation define OEM, whether it's OEM that in a header of encapsulation or active OEM specially constructed test packet. Came to realize that there is some inconsistency and might be discussion would be helpful to bring solution that make it useful for different protocols.
I'll do that for you.
Thank you, I appreciate it. Okay, so that was the problem statement. Looked at new encapsulations in SFC, beer, NVO3. That includes GUI, Geneve, VXLAN GPE, and beer. Okay, next slide. So we had some progress made in SFC and SH definition of interpretation of OBIT and how active OEM defined. RFC 8300 defined OBIT as when it's set, it indicates an OEM packet. And in a document which effectively addresses and discusses SFC active OEM, we agreed to clarify that setting this bit indicates that OEM command or data are in NSH context header or packet payload. This document proposes active OEM encapsulation. So can we go to the next slide? Because with the fact that we have OBIT and we have next protocol field, there are number of combinations. And this draft now defines the combinations. So if we have OBIT set and the value of next protocol is not one of OEM protocols, because we might have active SFC OEM, or we might have IOM, or it might be some other protocol, then their OEM data are included in either fixed header or variable length context header that follow directly the based header of NSH. So this example demonstrates that. So let's go next. If OBIT set and the next protocol is one of the protocols associated with OEM, then the payload that follows immediately after NSH header includes OEM data or command. And so this illustrates whether it's a fixed header or variable length context header. Next. If O bit is clear and next protocol is not one of the protocols associated with OEM, then this is a user data in the payload. Next protocol. If O bit is clear and the next protocol is one of the protocols associated with OEM, this is erroneous situation. Okay, next protocol. So looked at what happened in other protocols progress. Geneve, it was going through a working group last call, and there was a discussion, but the only change that authors did is they changed attribution of O bit from OEM packet to control packet. And which I believe still leaves the question of OEM identification in Geneve very ambiguous. Next slide. Well, with the fixed size header OEM, well, there is no change because Beer, I believe, already defined it, so it doesn't have O bit. It uses next protocol, and OEM type protocol already being assigned by IANA. And VXLAN GPE, yes, there was introduced O bit, but the draft expired, so I don't know how it will be revived, progressed. I would like to discuss it with authors if they're interested. We might find some solution for VXLAN GPE. Next slide. Well, again, appreciate your questions, comments. I don't see that this document has to progress very far. I'll be very happy if there will be some consideration of what we've done for SFC NSH, for other variable length encapsulations. And that will enable work on OEM for these network layers. Thank you.
Any questions to Greg? Anyone read the draft? Greg, I think it would be great if you ask for reading on mailing list and ask people to participate.
Okay, will do.
Thank you. Stefan?
Okay, so next presentation is about TI-LFA. Okay, just as a reminder, so TI-LFA stands for Topology Independent LFA, so it's an IP fast reroute mechanism. It is based on segment routing to build the backup path. However, it can protect any kind of traffic, whatever it's IP, MPLS LDP, or even MPLS RSVP, if you want, it could work. It could be seen as an evolution of LFA, remote LFA, and directed forwarding LFA, just one step further. The added value we see in topology independent LFA is that, first of all, it's topology independent. So with LFA, remote LFA, we always had an issue with the coverage because sometimes, depending on the topology, there was no possibility to find a backup path. And with TI-LFA, whatever the topology you could have, you will always have a backup path available, which is pretty good. And the other thing, the other benefit coming with topology independent LFA is that we are trying to optimize the backup path that we are using. So there was, so the document has been adopted recently, but there was bunches of comments received even before the adoptions. A lot of comments were about this notion of post-convergence path we were using, which was quite unclear, but we will come back to that a bit later. There was also some question about the scaling of the computation, especially if we are trying to compute queue space for each destination. Some comments were also pointing some unclear points in the data plane procedures, especially in case of SRM-PLS when PHP was involved. And also some other comments, but we will try to cover them in the next slide. So first of all, the post-convergence path. The idea behind TILFA is to try to provide a backup path which is, I would say, optimal. This could be this word could be a bit challenged, but this is the global idea. So let's take an example with this topology. So I have router X, which is there, with some ingress P1 and P4, which will send some traffic to P3 and P2. And if the XB link is failing, forget the fast reroute for a moment, the traffic will be, X will reroute the traffic on XH or XD, depending on the destination. So the traffic to P3 will be sent on XH, and the traffic to P2 will be sent on XD. But at the same time, during the convergence, P1 will also possibly reroute some traffic. So the traffic going to P3 will still use the path AX and then X to H, but the traffic to P2 will not be sent to X anymore. So P1 will reroute the traffic to C, D, E, F, and P2. What could be concluded from that? From the X point of view, I would say optimal and well-sized path is to use XH or XD link. So from a capacity planning point of view of a network, I need to ensure that when the XB link is failing, I have enough capacity on XH and XD link to support the traffic that was previously on XB. This is true, but not completely optimal because the sum of traffic on XB is not splitted on XH and XD because some of the traffic coming from P1 will go out from X node. So some of the traffic that was previously going through this path will be rerouted there. However, depending on the convergence order, so if P1 is converging before X, and if I'm sizing the XH and XD to support the traffic on XB, I'm oversizing a bit the link which are there. However, if X is converging before P1, my network sizing is good because I'm able to support all the traffic. So the idea behind TILFA is to try to reuse this capacity planning concept. So from the point of local repair point of view, we will try to use the next shortest path, taking into account the failure of the link. So if we take into account that the XB link will potentially fail and I want to protect against this failure, my, I would say, best optimal path would be on XH or XD. Okay, so the idea of TILFA is to build a backup path using what we are calling the post-convergence path. Okay, which is a well-sized path. This is an assumption in terms of network capacity planning. Some networks could do the capacity planning in another way. If people are not really happy with this post-convergence path idea of TILFA, they can still use the policy mechanism that has been defined in 1716 to be able to tune the backup path using other criteria rather than this post-convergence path or next IGP shortest path. The other comment that we have received about this post-convergence path is that it's not really the post-convergence path. Why? Because TILFA is a fast reroute mechanism, so it pre-computes a path for an expected failure. So let's say that I'm doing a node protection. I will pre-compute a path taking into account that this node will potentially fail. However, in reality, maybe the node will not fail. Maybe just one link will fail or a set of links will fail. So this leads to the fact that the backup path that I will potentially use is not completely optimal, because it's optimal from an expected failure point of view, but it's not really optimal if the failure that is happening is not the failure that I was predicting and protecting for. So that's why before, so we were using the notion of post-convergence path, but we have changed the wording to expected post-convergence path, because we are expecting the traffic to use this path. But yeah, maybe if the failure is different from the one I'm protecting, the post-convergence path will not be exactly this one. So in terms of update to address this post-convergence path concerns that has been raised on the list, so we have added some reference to the RFC 7916, which was already talking about the path optimality issue, especially in LFA and remote LFA environment. So we also changed the wording from the post-convergence path to expected post-convergence path to deal with this potential not full optimality of the backup path. And we have also really explained the use case and the benefits of using this post-convergence path or expected post-convergence path in terms of I don't need any more policy to implement in my fast reroute if my capacity planning rule is following just the IGP shortest path. So it's really easier to deploy. Now, regarding the scaling considerations of the Q-space computation, that's not really an easy issue because an easy topic, because this is one of the points that we need to discuss for this draft is what is the level of detail we want to put in terms of computation algorithm. Do we expect to have a full definition of an algorithm to compute the backup path, or are just the concept that we are presenting in the current version are enough? Because today what we are doing is just to say that okay, we compute the post-convergence path, so we compute an SPF based on taking into account the failure of the component, the SRLG, the node, or the link, and then we need to express this post-convergence path as a loop-free path by using node seed and adjacency seed. But the challenge is how to compress this label stack to be minimum, and here we can reuse the P-space and Q-space concepts that were defined in the remote LFA draft, so RFC 7490. And this RFC was already talking about the scaling issue if we are trying to compute a Q space per destination. So this means computing a reverse SPF routed at each destination, which is a bit painful. So remote LFA was restricting itself to compute it just from the point of view of the remote end of a link in case of link protection to reduce the computation. But here we are not, at least today, defining a full algorithm. We are just defining the principles of the technology. So we are pointing the scaling considerations to the paragraph which is already existing in the remote LFA RFC, and we just say that it will be implementation dependent to find the good trade-off between optimization and computation load. That's our proposal today to deal with that. Now, in case of data plane procedures, so we did some work on mainly on the text, try to be more consistent in the wording we were using, because sometimes we were mixing SR data plane words like push, next, continue, and so on. And sometimes we were using MPLS, pop, push, swap, and so on. So now we are more consistent and we are using only SR terminology. We have also introduced a normative language, which was clearly missing in the previous version. And the important point is that in case of SRMPLS, there are special behaviors to deal with, especially when penultimate popping is involved. So just to give you one example, when I'm trying to protect a link, which is called SF, and let's say that I have an incoming packet, so SRMPLS, packet coming with an adjacency seed at the top of the stack, which is the SF link, and a node followed by a node segment going to a node T. So the basic behavior of TILFA link protection will be to create a backup path which will merge back on the F node. So we will create a repair list, which is called here RTF, followed by a nodal segment going to F, which is merging back us to the remote end of a link. However, if our repair list is, so the RTF, which is also a combination of adjacency segment and nodal segment, is terminating by an adjacency segment which will forward the traffic on F, we have an issue in case of PHP. Because node F, the node F is not expecting to receive the nodal segment F because PHP has been requested. So what we need to do in this case is to not push the node F. We just put the RT list on the nodal segment. So there is a special behavior in case of PHP. So the draft was also limited in the previous version to the local SRLG case. So we have removed this restriction. Normally there is nothing preventing that to make it working with global SRLG. And one of the last points that we have added is the relationship between TILFA and the different SR algorithms. Because when the idea of TILFA was built, it was at the time where only the default algorithm was available in segment routing. So the default algorithm is just the regular SPF. But now we have the strict SPF, and we have also the flex algo. One comment that has been raised is that when I'm trying to protect a nodal segment which is using the default SPF, and when I'm using a nodal segment in the repair list which is also using the default SPF, there is a possibility that a local policy may override the path that the nodal segment is using, because the default SPF algorithm allows an operator to add local policies that could override this path. Which the consequence of that is that possibly the path may not be loop-free anymore if the local policy is changing the path to something which is different from the shortest path. So one remark about that is that such local policy could even break today LFA or remote LFA or even the IGP shortest path. It's not something related to TILFA. So it's really a matter of network design to create local policies that will keep the network loop-free. So that's why we think that it's a responsibility of the operator to ensure that this local policy will not break the loop-freeness of the shortest path. The other solution, which could be to protect an algo 0 not seed by using nodal segments that are using the algorithm number 1. So algorithm number 1 is called a strict SPF, and this strict SPF is exactly the regular XPF, except that we can't have a local policy. Okay, it can't be overridden. It's always the shortest path. So by using strict SPF instead of algo 0, sorry, in the repair list we ensure that the loop freeness will never be broken. The second point about FlexAlgo is that we could make TILFA working with FlexAlgo. We just need to ensure that if I'm protecting a node seed which is using a particular FlexAlgo, I just need to use in the repair list some node seeds that are using exactly the same FlexAlgo, and in all my optimization algorithm, instead of using the regular SPF or reverse SPF, I'm using the same CSPF constraints that are part of the FlexAlgo. But in theory, it should work. So next step. So we tried to address all the comments that we have received on the list. I hope that we have not missed any, but if we missed some comments or if you have additional comments, feel free to raise your voice. There are, of course, some points to discuss, especially this last point about TILFA and SR-algo relationship. And if we want to set a strict rule, for example, to protect a node seed with algo 0 only with some nodal segments with algo 1, do we want to set it as a must or not? And yeah, the main point also that we need to agree on is what is the level of details that we are expecting in this document in terms of computation details? Is it enough to set only the concept as we are doing today, or does the working group want to have a full algorithm detailed in the document?
So Stuart, Brian, I'd like to comment on your previous slide. So I'm kind of worried that we're losing the unconditional correctness that we had in the original fast reroute concepts, particularly as if anything goes wrong in fast reroute, not only will you have lost all the reasons that you've put it there, but it's going to be an absolute devil to debug, because these are really transient. The bugs will be transient because these properties are only supposed to be in place transiently. Now, I suppose your second suggestion is probably the least worse, in that fundamentally you should really repair within the topology that that you're operating in, and that would suggest that unless you do two, you really are headed off to all kinds of very strange bugs in your network.
I agree.
I would support the suggestion, perhaps stronger language to only support single algorithm realm with regards to computation. And perhaps we could, I don't know, talk to LSR as well to see their opinion.
So, I mean, with respect to that point, I think perhaps for, option one of, local policy, sort of spelling out the scenarios where, or an example scenario where you could create loops even in a normal, unexpectedly, spell that out a little better so that, what level of consistency do you need, like, to avoid that and mainly just in the topic of the local policy being in fact TILFA, right? Yeah. What consistency do you need to avoid loops?
Yeah. The main, it's not really an issue, not a concern, but it sounds just strange to me to say that, let's say that for algo 0 node seed, I'm just able to use algo 1 node seed, and for let's say that we want to apply this to flex algo, this means also that we need to define a kind of sibling algorithm for each flex algo to be a strict flex algo.
Yeah, I agree.
Why not? But yeah, this means the consequence of that is that we need twice times the number of algorithms that we are really requiring.
I'm not sure whether you need twice, Stuart Bryant again, whether you need twice as many algorithms, but I think the fundamental is that you need to operate entirely within a single what I call topology. I'm not sure whether that's the right term, so that there is always mutual consistency in the network in terms of what the paths and what the alternative paths are, and that packets are trapped within that topology.
That's true.
Anything else, I think, is a route to all kinds of, as I say, really serious transient bugs that are so difficult to debug that people will never deploy it.
I agree.
Peter Pshirak from Cisco. So I don't think we need a strict topology or algo for every regular algo that we define. I mean, it has been expressed here that we can have these loops with the regular algorithm, right? So I think that would be an over-engineering, honestly.
Okay.
Peter, your statement is really generic. So from your point of view, we should allow TI-LFA with non-congruent algo spaces. Is it what you're suggesting?
Absolutely not. I think the LFA should be computed within the context of the single algorithm.
Okay, so we all agree on the constraints.
Yeah.
So next up, we have a remote presentation. Oh, perfect timing from Stephen Wood.
Hi, can you guys all hear me okay?
Almost there.
Okay, great. Jeff, are you hearing okay?
Yes.
Am I coming? Good, very good. Excellent. Okay, so this is kind of first step from after the Montreal meeting where we were presenting on possible SD-WAN interworking models. And so this is our first cut at a draft to define OSE service delivery models for interworking between different vendor SD-WANs. My name is Steve Wood. I'm from Cisco. Work in SD-WAN architecture and technical marketing. And my contributors are Bo Wu and Chin Wu from Huawei, as well as Conrad Meneses from HP. Please continue. So just again, overall motivation for what we're trying to do. We're not trying to create a standard protocol and management protocols, control protocols for the interoperability of devices in an SD-WAN. We are trying to create interworking protocol and standardization between SD-WANs at well-defined interfaces. Next. So this is our reference architecture, which we have created in the Open SD-WAN Exchange as part of the Open Network Users Group, or ONUG, of which I am one of the chairs of this working group. So this model attempts to define the interfaces around which we will standardize. You can see them, the interfaces around the outside. Focus of today's presentation is primarily interfaces to allow for communication and setting of path management information, sending of path management information into the SD-WAN transport network. So next slide. So this gives a better view of how the use case maps right now to the previous one. So we have two use cases we're focused on right now. One use case is the setting up path management policy in order for the vendor within each SD-WAN domain to do the proper enforcement of that path management policy.
Let me interrupt you for one moment. Could you sort of go back 30 seconds, because your voice was completely garbled by the transmission. Thanks.
Okay, go back.
No, just start from the beginning of this slide.
Oh, so at the beginning of this slide. Okay, this slide covers the initial use cases we have in the draft. You can see up here that we have a definition of path management service model. The goal of that service model is to define the parameters needed to put particular applications and flows on a specific path within an SD-WAN. So that's our use case number one, is to define the path management policy service model and the definition of the enforcement, how that path management service model should be enforced within each SD-WAN domain. Okay. The second use case or model we've created is a gateway service model, which defines the interoperating NNI between two SD-WAN, as you can see here, the gateway edges for achieving a connection between two SD-WAN vendors. So of course, there are many ways to do this. So we are trying to lock down a standard way so that it can be supported in all different vendor controllers. Okay, let's go to the next slide. So this gets into the structure now of the Yang model for each of those use cases. So you can see here we have defining a set of parameters to allow communication between an upper layer orchestrator, which is not defined as part of the RFC, but the idea is to create a set of Yang models which could be used to create an API that could define reachability parameters between the gateways. So we have a reachability service model, which has roughly the functionality seen here. OSC gateway creation within each domain, the gateway configuration for BGP or multi-protocol BGP control plane pairing, as well as the underlay connection setup and the overlay tunnel setup, either a GRE or IPsec tunnel. In addition, we have an API, we have a model that allows us to do a segment instance creation, so a cross connect between the segments on one SD-WAN domain and the companion SD-WAN domain. As well, the Yang models contain a path service model that is set up to specify all the parameters needed for dynamic path selection for a cross-domain traffic configuration. Next slide. Okay. Gets here into a little bit more of the guts of the gateway service model design itself. So this is specifically looking at some of the details of the gateway service model. We have here, as you can see, a list of OSC gateways, basically the ability to create a gateway or query for a gateway list within an SD-WAN domain. And then you can see that we have as well tunnel parameters, BGP peering parameters that control control plane configuration. So we have two options there. We have reachability exchange using multi-protocol BGP.
Steve, the Meet Echo team wants you to disable your video so that the audio goes through, so that we can avoid issues. Thank you.
Okay. Hopefully this will be better. Okay, great. Okay, so we have two options for control plane pairing. One is using multi-protocol BGP-based EVPN or L3 VPN style of communication or interworking. And then we have standard simple option A VerFlight type of control plane and data plane interfaces capability. So this capability could be negotiated between controllers, what's supported, and then set up. The data plane configuration parameters that we have here are for setting up GRE encapsulation. As my voice comes, hearing some clicking. Okay. And also for added security, we have IP-based IPsec VPN. So we're expecting, for the most part, that the IPsec VPN will be the option that's used. All right. And then you can see as well, we have a segment mapping list allow the users to basically mapping and cross-connect of segments definitions between SD-WAN islands. Okay, let's go ahead to the next slide. Okay. This is the path management service model design. So the path management policy is really an ordered list of traffic classifiers, along with an SLA list and then a selection mode or preferred path selection policy. Okay. What we will do is have a first match against the traffic classifiers that will be then will be applied to the link and path policy, which is then contained in the SLA that's associated with those links and paths. So you can see that tree model diagrammed up here. But the idea here is that we have the definition of application or application flow with classifiers. You can see that is attached to a link and path definition policy. So which link I should prefer based on the conditions on the link, or based on my policy if I want to prefer a specific private network or a network that has a specific business priority, which I define, for example. And then any kind of link and path performance SLA information. So we have a name for that SLA. We have delay, parameter, loss, jitter, mean opinion score as the main performance as definition that parameters. Yes.
Steve, we lost about 50% of
I'm
what you're
sorry about
saying.
this, guys. I'm not expecting such a bad performance in the middle of the night here. I don't know if this is going to work or not, because I can kind of hear some clicking on my end of the line. Anyway, I'll try one more time. But yes.
Steve, one of your co-authors is here, and we've been losing about 60-70% of what you were saying. So she could probably do
okay,
it.
We have that backup. So please go ahead. I apologize.
And thank you for doing this.
Yeah, thank you. And actually, Steve, okay. Sorry for the connection. And this path management service model is actually used for the traffic for cross-domain. The domain A belongs to one vendor domain, and domain B belongs to another one. So because in ONAC's reference model, that the orchestration layer is a quite light one that just orchestrated for the application aware service policy, or other like the previous one that Steve just described about the ONAC, the gateway NNI interface connection setup model. So these two models can help the ONAC this ONAC's reference model architecture to describe what their service requirement is. Actually, they don't want to touch the domain A's device setup or the infrastructure setup. All the ONAC's reference framework is based on the each domain's infrastructure setup belongs to the each domain's controller, SD-WAN controller, and orchestration will just help how to set up the cross-domain traffic to that kind of policy. So, and the path management here is a very typical SD-WAN service that it needs to, that it means that in ONAC scenario, there will be like multiple paths that for each site that connected to the WAN network, maybe like private MPLS network or the internet network. So, but in the orchestration have the two domains topology or the end-to-end SLA's information, so they can divide the cross domains traffic SLA's requirements divided into two separate domains. Then the end-to-end SLA can be guaranteed. So that's this model.
So we'll go 5 minutes over till
Okay.
11:05, just so you
Okay.
have a reference point.
Okay.
Because of the technical difficulties and so on. We'll
Yes,
do that.
so I will move on to the open issues, because this is just a very initial draft here, and we are working on to make it more clear and more complete, because right now the ONAC's service modeling is a customer facing model, so they rely on the infrastructure's control plane protocol defined in IETF, because that's IETF's expertise, and ONAC also noticed there is some work on the IETF to do this kind of work. So we will update our service model depending on those work in IETF, and also we still have other open issue with past specific domains, jitter loss, that kind of SLA measurement requirements. How can we do that? That's an open issue too. So this time it's a quite initial draft. So we'd like to have more review and feedback. We can like to collect more review and feedback to help us to create a very yes, almost done. Yes.
Wim Hendricks from Nokia.
Okay.
I think it's good work that it's going on in general. I was wondering, with respect to the services itself, like layer 2 VPNs and layer 3 VPNs, are you in? I haven't really read the draft in all details. Are you going to reuse L2SM and L3SM for that in this draft, or because the focus of this draft is mainly about the gateway and the interoperability,
yes,
as well as the path management. Mm-hmm. But what are you? Is the proposal to be used for, let's say, L2 or L3 VPN
actually,
with respect to SD-WAN? Are you?
We don't touch that part, because it depends on the domain-specific implementation that belongs to the service controller in each domain. That how can those you use EVPN based SD-WAN or L3 VPN based SD-WAN? It depends on the different domain.
Yes, but I think IETF did some work on L2SM and L3SM as an abstraction layer on top of that. So I think it would be good to also leverage that work somehow in this space.
Yeah, ONAC has their own specific requirements, because they don't. They just describe the enterprise own network. They don't design this reference architecture for the managed service provider. They don't touch that scenario.
So Wim, are you talking about between the gateway devices, L2SM, L3SM? I haven't looked at those drafts, but is that what you're talking about?
Yes, yeah. Actually across the board, because what you're trying to define is an end-to-end service. Right, so we should actually try to abstract the implementations underneath And I think then it's not only about interconnection, it's not only about the path selection mechanism, but also the end-to-end service which you define either within or even across the different scenarios. So,
we'll certainly take a look at that. But as Bo was pointing out, the service is almost like a piecewise service. It's SD-WAN domain 1, whatever gets done in there, gateway, SD-WAN 2. So we're trying to stitch things together. We're not trying to create a single end-to-end.
We can discuss it offline, but what I'm getting to it's to have a full service definition for SD-WAN as a service, as a complete service suite, rather than doing a bit here and a bit there, so that you have one definition and you say, okay, this draft is what you have to look for. This is your SD-WAN service definition model, and this will not only cover the path management, not only the interworking, but also the end-to-end service layer.
Yeah,
and I think if we do that,
yes,
we probably serve the industry a good. It's good for the industry because then they can say, okay, this draft, this is your reference model from Yang for SD-WAN services.
Okay.
So we should probably cut this off here. Potentially we could have more discussion on Friday, but also discuss this offline. And thank you, thank you for stepping in, and we apologize for the technical difficulties. Thank you. And we have another session on Friday, so we'll see whoever wants to be there then.
See you on Friday.
Maybe they can consolidate. Yes.